All right, so this is the single one. The first equation I have here is a decomposition reaction because the reactants break down at the end. So in order to balance this, first list the reactants. So you have Ni and O, and then you have 2Ni and 3O on the left side, and then on the right side you have 1Ni and 2O. Now, the way you would balance this is first put a 2 here, which changes that to a 2, so now the Ni is balanced. And to finish with the O's, you would have to put a 3 here and a 2 there, so that way they both equal 6, but that changes this 2 to a 4, which means you have to put a 4 over here instead of that 2, like that, and then that makes this 4. And there you go. The next equation is a combination reaction. This equation is a combination reaction because the reactants combine to form one product and not two products. So the way you would balance this is first, again, listing your elements or reactants, Na and Cl, and then listing how many you have on each side. So the left, there's one Na and 2 Cl. And on the right, there's also one Na, but only one Cl. So the first thing you would have to do is try and balance the Cl. So you would multiply this one by 2, which makes this a 2, which balances those. But that also changes this one to a 2. So all you have to do is then put a 2 here, changing that to a 2 as well, and then put in the 1 here. Don't forget to do that, and then that's it. This type of chemical equation is a redox. Now, redox equations have a reduction and a reaction with oxygen in the same equation. So, the way you would balance this is list your reactants. You have two H's and two F's on one side, and then one of each on the other side. So simply putting a 2 here and then filling in the rest with 1's balances the equation. This type of equation is called a single replacement equation. And what that basically means is that the reactants just switch places with one another. So in this instance, the Zn and the Cu switch places to make this a single replacement reaction. So again, to balance, just list your reactants on each side. There's Zn, Cu, and Cl. Now, this equation is actually really easy because you have one of each on every side, or they're already balanced. So there's one Zn on the left, one Cu on the left, and 2 Cl. And then on the right, there's one Zn, 2 Cl, and 1 Cu. So you're already good with that one. Just remember that you have to fill in the ones like that, and there, and there, and there. This type of chemical equation is a combustion reaction, and that just means that it's a reaction that has oxygen that produces CO2 and or H2O. So, as you can see here, it is a reaction with oxygen that produces CO2 and H2O. So, that being said, let's balance it. So same as always, you just list all of the ones that you have. Now, this is where a lot of people will mess up. In this specific equation, you have to separate the C, the H, and the O because they do change places when they switch to the right side and become products. So that's just one thing to be mindful of. So on the left side, we have one C, four H's, and two O's. And on the right side, there's one C, two H's, and one O. To balance this, first the C is already balanced, so you don't have to worry about that. Then you multiply this H times 2, which makes this a 4. It takes care of the H's. And, oh, actually, you know what? I messed up. This is where a lot of people will mess up. There are actually 3 O's on this side because there's one here and one there. So that's 2 plus this one is 3. So yeah. So multiplying this side times 2 turns this into a 4. And to fix that on the other side, just multiply this times 2, and then that gets you to a 4 as well. And you're done. Last kind of equation is a double replacement reaction. So for this one, basically, the reason why this is a double replacement reaction is the NO3 switch with the CrO4. So again, same thing as always, list your reactants, Ag, NO, and then K, and then CrO. Then just list how many you have on each side. Ag is 1, NO is 3, K is 2, CrO is 4. On the right side, Ag is 1, CrO4 is 4, and then NO3 is 3 again, and K2 is 2. So for this one, and again, generally that's what will happen when you have double replacement equations, is that they will already be simplified because all that happened in the reaction is they just switched places. The same goes actually for single replacement as well.